All right, this next one is on experimental and theoretical probability. The first definition I'm going to look at is the relative frequency. Okay, if you notice there on the bottom, okay, the relative frequency calculation, okay, like how often something occurs. That's the best way to think about it. Relative frequency, about how often it occurs when you do something. So the definition or the formula says the number of times something occurs. Okay, you could be flipping a coin, okay, say you're looking for how many times you're going to flip a coin 20 times. Okay? If you flip it 20 times and you're looking for how many times it head pops up, that would be the numerator, number of times that event occurs. Okay? That's the numerator. Denominator is the total number of times. If you flip it 20, the 20 would be the denominator. And that number that comes out is the relative frequency. About, on average, how many times has occurred. So what would you expect the relative frequency to be on flipping a coin to be heads? About how much would you expect? 50. 50. Will it always be 50? We always get 10 heads, 10 tails? Not always, but it should be in that relative area. Okay? So that was the first thing I want to make sure we get to. All right? Next thing, we'll look at the actual another definition. Experimental. Okay? Experimental is what actual happens. The actual thing that happens. Okay? So experimental probability, can't talk there. Experimental probability is a probability that is based on repeated trials of an experiment, the actual trials themselves. Okay, the formula is the number of times that it occurs over the total number. Okay, this is what's actually happening. Experiment. You guys run experiments in science class a lot, sometimes in math occasionally. Okay, it's what actually is happening. All right. This is not the same as what you're going to see in a second. Theoretical. Theoretical is in theory. Okay, this is what should happen. So if you're flipping a coin, my favorite example for this, if you're flipping a coin, your experimental might not, you might not have a 50% heads, 50% tails. Okay, your experiment will be different. Your theoretical, on the other hand, will be 50%. Okay, you will be at 50%. All right. And we'll go look at the theoretical one. Theoretical. I missed theoretical. All right. Well, we'll get to it in a second. Example 1. All right. So the bar graph shows the results of rolling a number cube 50 times. Okay, we already described what a number cube looks like. We played it yesterday. What is the experimental probability of rolling an odd number? Experiment. What actually happened? In reality, is not always the same as theoretical. So look at the thing. How many different numbers do we have as odd numbers? Well, that's 1, 3, and 5. We can look at the bar graph and notice that 1 has a total of 10 times. They rolled a 1. 10 times would be, or 8 times for 3, and 11 times for 5. So if you were gambling yesterday, you want to pick, 5 or maybe 4, right? Yesterday. So let's look at it. So 10 plus 8 plus 11, those different times, 10 plus 8 plus 11. Add those up, you had a total of 29 times in total. You had that favorable outcome, the odd number. Okay, so that would end up being a 29 out of 50, which can be simplified to simplified as a percent or decimal, which would be 58%. Okay, it would be 58%. So your experimental wasn't too bad, considering what do you think the theoretical would be for this one? In theory, what is your probability of rolling an odd number? How many odd numbers are there? 3. How many total outcomes are there? 6. 3, 6 is what percent? 50%, right? 50%. So in this case, 58%. If you were guessing odd numbers, you'd have a pretty good night that night, right? Okay, you had more experimental success than you would technically theoretically. And that's what gambling really is, right? Isn't it? Okay? You want to beat the odds. That's your goal. Okay? Next one. Two. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? Okay, it rains 2 out of the last 12. So that's kind of, what ratio does that kind of give you a little bit? 1/6. 1 day every 6 days, right? It's going to be raining. Okay, so your first question might also be is how many days are in April, right? Okay, we'll figure that out, which I think is 30. Okay, so number of times an event occurs. So we said it ends up being 2 out of 12, which is 1/6. We just said that. Okay, 1/6, one rainy day every 6, and then we're gonna go and make a prediction. Multiply the number of probability of rainy days by the number of days in April, which we said there are 30. So it'd be 5. 5 rainy days. Okay. You can also use the equation, or not the equation or the similar ratios. If you know that it's 2/12, or in other words, 1/6, we can set that equal to 30 days. 6 change to 30 by multiplying by 5, multiply this by 5, because we should expect to have a total of 5 rainy days at that continued trend. Now, this is a forecast. This is theoretical. Is this exactly what's going to happen? No, we don't know for sure. We're predicting the future. Again, go be a meteorologist. Go be a meteorologist. It's not a bad gig considering you can be wrong every day. Okay. Next one. 3. You randomly choose one of the letters shown. What is the theoretical probability? Okay, this is the theoretically what should happen. Okay, randomly choose one letter shown. Okay. I don't see any question on this one.
Maybe it's 0 because there's no letters.
Yeah, exactly. I think this one's missing. It's not popping up. Apparently there's 3 vowels here. You see something I don't? How about I close it up and go the other way real quick? It was there earlier. Let's try it again. Rainy days, go there. There it is. There's our letters. We'll use those. Okay. Randomly choose one of the letters shown. Where's the theoretical probability of choosing a vowel? Vowels are what? A, E, I, O, U. They even have sometimes Y, right? Okay. So we have how many vowels we have? 1, no, 2, 3, and that's it. 3 out of a possible 7. So the likelihood, the theoretical probability is 43%. Okay, because 3 out of 7 is 43%. 3 divided by 7, 43. Okay. Your definition of theoretical, I kind of summarize it. It's what the theory says it should happen. Okay. That's different than experimental. Experiment is what happened. Theoretical is what in theory should end up happening. Okay. Still favorable outcomes over possible. All right. Last one. Hopefully the last one. Oh, actually, there's 2 more actually. The theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6. The wheel has 3 bobblehead sections. How many sections on the wheel? So if you have the favorable outcome is 1, that's the numerator, out of 6. Well, if it's 1 out of 6, but we actually don't have 1 favorable outcome, we have how many favorable? 3. So that's how many times bigger? 3. So how many total spaces are there going to be? Well, if the numerator increases by 3, that means the denominator also has to increase, multiply by 3, which would be 18. Okay, so we do the same thing. Okay, we have 1/6, which over 3, go top times top, bottom to bottom, gives you a total of 18. Okay, 18 total spaces. And the last piece. Okay. Bar graph shows the results of rolling a number cube 300 times. That's a lot of rolls. What is the experimental probability of rolling an odd number? Again, odds are 1, 3, and 5. We're talking about experimental, means what actually did happen. So if you look at the side here, we got what? 48, 50, and 49. Those would be the favorable outcomes according to the question. So we're going to go ahead and add those up. That's 147 out of 300, right? 147 out of 300, and you can change it to a percent, which is 49%. Okay. Next one. How does the experimental probability compare with the theoretical? Well, what should have happened? How many odd numbers are there? There's 3 out of 6, which should mean we should have a total of 150. We should have 150 odds and 150 evens. We should have that. So how does that compare? Okay, well, in this case, we're a little bit low, right? We missed it by what? 1, 2, 3. We missed it by 3 rolls of the dice. So the person who say you bet on evens, he did a little bit better than the guy who bet on odds that night. Okay. C, last part. Compare the experimental probability in part A to the experimental probability in example 1. I'm not too worried about that one there. All right. That last thing is your examples to try for yourself to see where we're at. Give these a shot real quick. Okay. And there you go. Probabilities there. I'll freeze it. And then here's the answers.